Hello everyone, welcome to the third video of my channel. In this video, we will talk about Retrieval Augmented Generation, or RAG for short. If you ever use a large language model before, such as ChatGPT, you could use it to ask any question you wish. But how do you know that the answer provided is correct? You could ask it to provide citation or where it get its data from, but it wouldn't tell you. Now, what you could do instead is to create a RAG. You would have, for example, in my case, I have a list of articles that have been peer reviewed. So I have high confidence that these informations are correct. Okay. So what I do is I extract text from these articles, embed them as vectors, and store them inside Chroma. And then if I have any query, I would try to find all the related articles that are similar to this query using the cosine distance. I would feed the query and all the related articles into a large language model, and then ask the model to provide an answer. Furthermore, provide citation to the answer as well. If it doesn't know the answer, then we ask it to say, I do not know the answer to that question, right? So mainly we try to reduce hallucination. So let's go to the program really quick. So here we import Panda, chromdb, OpenAI. PDF is the library that we use to extract text from PDF. And here we have the natural language toolkit to remove stop words, tokenizing words. Now you could use tokenizing sentences, but I felt it's not needed. Maybe it could be something I could experiment in the future, but for now we just keep it simple, and then we stem the words. Okay. So first of all, we gotta have some API key from OpenAI. We create client. So here we create a function to extract the PDF. Okay, I store the file name, I store the page number, and I store the text. Okay, and then we pre-process the text where we only want letters and numbers and nothing else. We lower it. We remove all the stop words. We tokenize the words, and then here in this specific line, we remove the stop words. Okay, and then we stem it. And then we join all the text together, okay? So that's how we pre-process the text. Now, you can't just feed the entire page or the entire article into an embedding model because that would be too large. So you have to split them up. So here I like to divide them up 100 words at a time. So here in this part, we encode the text. Basically, we turn the text into vectors, right? So if I have text, over here I go one page at a time, and then I divide the text into 100 words at a time, and then I pre-process it, clean it up, and then I would use the embedding model. Here I use the text embedding ADA002 and convert it to vectors, okay? And then I store it as a dictionary here, right? I store the file name, the page number, the text, and the embedding, right? And then I send that to my vector database Chroma, okay? And here is the function to retrieve, right? If I have a query, so here first I embed the query, and then find all the related text that are has a small cosine distance to the query. Take all the document that we found and put them together as text, and combine it with sources and so on, and then we turn that into a prompt. And then we ask the model, we ask the model to provide a detailed answer in bullet form to the query and use only provided resource, and also, of course, provide citation. If it doesn't know the answer, please say, I do not know the answer. Okay. So if you wish to see the code, I can provide you the link to my GitHub. But for now, we're just going to quickly go over it. So here we extract the text. So here, notice I use new because I extracted a lot of articles already, and I found some new one. So I'll put a new one in there. Okay. So that's what the new is. And here I just look at, what does it look like. So here we have file name, page number, and the actual text, the raw text. And when you pre-process, what does it look like? It looks pretty clean. Okay, all the punctuation has been stem and so on. It looks a lot cleaner. And then we encode it. Okay. Sometimes I like to save it, but so that I don't have to embed multiple times and save on the money. So here's what it looked like. Okay, I save the file name, the page number, and the text, and the embedding. Okay, the embedding is a vector. Whenever you want to delete your collection, you can do so. But anyway, right, this is how we build. Right, we embed the vectors into Chroma. Okay, and here, let's see. So, for example, if I have a question, okay, if I have a question, I embed a question, and I find all the document that's related to the query, right? So I would have a whole bunch of documents here. Okay, these are the IDs of the documents, and these are the distances, the cosine distance. These are the file name and the page number, and these are the actual documents. Here I save the raw text instead of the pre-processed text because we want to feed that into the large language model. Right, it will be more accurate. Right. So here, let's see in action. So what is the optimal pH for aquaponics system? All right. It will tell us, these information. It will tell us where they get it from. Here in this case, they didn't list down the page number. Sometimes it does that. Sometimes it doesn't listen to us. If I do it again, we would provide correct citation. Sometimes it does. Sometimes it doesn't. Unfortunately, something I have to play around here. So here, right here, it provide page number. Okay. So what else can we do? Let's see. How to prevent algae in aquaponics system. Let's see what we have. Again, right, it would only provide an answer using the sources that we provide to the model. So here, right, they tell us the answer, and they tell us some of the citation. Okay. Now, what if you ask a question that it doesn't know the answer to? Right? Is Goku stronger? Oh, that's Goku. Is Goku stronger than Vegeta? Okay, so let's see. It should know the answer, right? It should say, I do not know the answer. Okay, because we only ask the model, or we only feed the model the information on aquaponics using the articles that I save in a folder. Okay, right. So I hope you guys enjoy this quick video. In the future, I can provide the code or the link to my GitHub once I finish. All right. Thank you for listening. See you.